Now, in the previous video, I talked about how a battery works, and I said that we've got a voltage associated with the cathode reaction and voltage associated with the anode reaction. So how do we figure out what should be the voltage of this battery, assuming we're at reference conditions, meaning that we're at 1 molar all the solutions? Well, we had to look at the individual reactions. We've got a voltage associated with the anode, Vn, and this is going to be the voltage associated with Z going to Z plus and E minus. And we've got a voltage of the cathode being the voltage of X plus E minus going to X minus. So really what this should be is the voltage of the cathode plus the voltage of the anode, because if we add these two together, we're going to cancel out the electron transfer. But here's the thing. We don't keep tables of cathode voltages or of anode voltages. We don't keep tables that tell us the voltage associated with oxidizing something. We only have what are called standard reduction potentials. And what a standard reduction potential describes is the basically voltage associated with taking some compound and reducing it. So how do we go from these tables of reduction to values for oxidation? It's surprisingly easy. All we do is we take the negative of it. So if we take the negative of this reaction, we'll get Z plus plus E minus goes to Z. So this here is a reduction reaction. So if we know the value, the voltage associated with this, if we just take the negative of it, we'll get the voltage of this reaction. And so what we get is that the voltage of the battery, the reference voltage, V0, is just the voltage of the cathode reaction minus the voltage of the anode reaction. So if we look through tables of standard reduction potentials, and these are available through the course website, all you have to do is look for the reactions you're seeing, but they don't necessarily have to be going in the correct direction. For the anode reaction, it's going to be backwards. You're going to see it losing electrons. But you're going to take the voltages off that table and just put them in here. So if you've got a voltage for the cathode and a voltage for the anode, if the anode is negative, the minus negative is going to be a positive. And this is how you're going to figure out the V0, reference voltage. Now the reference voltage is going to come in handy when we start using what's called the Nernst equation. And the Nernst equation tells us the voltage of a battery, assuming we are away from 1 molar concentration solution.